Have you ever looked up at the night sky and wondered about our place in the universe? For centuries, humanity has gazed at the stars, but one of the most profound discoveries wasn't about a distant galaxy, but about the very ground beneath our feet. Today, we're retaking a journey through time and space to explore the undeniable evidence that proves our world is a sphere. It all starts with this breathtaking view. The iconic blue marble, a stunning sphere of blue, white, and green, hanging in the blackness of space. This image, captured by astronauts, is perhaps the most direct proof we have. But long before we could venture into orbit, brilliant minds had already figured it out using nothing but observation and logic. Let's travel back more than 2,000 years to ancient Greece. Philosophers like Aristotle weren't just thinking about ethics and politics. They were also keen observers of the natural world. One of their most compelling clues came during a lunar eclipse. As the Earth passed between the Sun and the Moon, they noticed something crucial. The shadow our planet cast on the lunar surface was always round. No matter how the Earth was oriented, the shadow was a perfect circle. Aristotle reasoned that only one shape could consistently cast a circular shadow regardless of its orientation, a sphere. If the Earth were a flat disk, its shadow would sometimes appear as a thin line or an oval, but that's never what we see. This simple, elegant observation was one of the first major steps in understanding our planet's true form. Building on this, another Greek intellectual, a librarian named Eratosthenes, performed one of the most famous experiments in history. He heard a fascinating report from the city of Syene in southern Egypt. On the summer solstice at high noon, the sun's rays shone directly down a deep well, illuminating the very bottom. This meant the sun was directly overhead. But in his home city of Alexandria, to the north, this wasn't the case. On the same day and at the same time, a vertical stick, or gnomon, cast a distinct shadow. Eratosthenes realized this difference in shadow angles could only happen if the Earth's surface was curved. If the Earth were flat, the sun's rays, being parallel, would create the same shadow angle everywhere. He measured the angle of the shadow in Alexandria and found it was about 7.2 degrees, which is about 1/50th of a full circle. Knowing the distance between Alexandria and Syene, he did the math. He multiplied that distance by 50 and came up with a remarkably accurate calculation for the Earth's circumference. This wasn't just theory. It was a mathematical demonstration of our planet's spherical nature, done over 2 millennia ago. But you don't need to be an ancient Greek philosopher to see the evidence for yourself. You just need to go to the beach. Stand on the shore and watch a tall ship sail away towards the horizon. You won't see it simply shrink into a tiny dot. Instead, you'll witness a fascinating phenomenon. The hull, the bottom part of the ship, will disappear first. Then the mast and sails will gradually sink from view, until finally, the very top vanishes. This happens because the ship is sailing over the curve of the Earth. It's like watching an ant walk over the top of an orange. Conversely, when a ship approaches from the distance, you'll see its mast first, followed by the rest of the vessel. If the Earth were flat, the entire ship would simply appear as a small speck and get progressively larger all at once. This curvature is visible on a larger scale as well. Think about time zones. It's midday in London while it's early morning in New York and evening in Tokyo. This is only possible because the Earth is a rotating sphere. As it spins, different parts of the planet face the sun, creating the cycle of day and night. On a flat, stationary Earth, the sun would illuminate the entire surface at once. Everyone would experience sunrise and sunset at the same time, which we know isn't true. Let's look up at the stars again. Travel plays a fun trick on our view of the night sky. If you live in the northern hemisphere, you're familiar with the North Star, Polaris. It appears almost stationary in the sky, with other stars circling around it. But if you travel south, towards the equator, you'll notice Polaris gets lower and lower to the horizon. Once you cross the equator into the southern hemisphere, Polaris disappears completely. In its place, you can see new constellations you've never seen before, like the Southern Cross. This change in the visible constellations is powerful proof of a spherical Earth. On a flat plane, everyone, regardless of their location, would be able to see the same sky. The only difference might be the angle of view, but you wouldn't have entire sets of stars visible to one half of the world and completely hidden from the other. The fact that your location on the globe determines which stars you can see is a direct consequence of standing on a curved surface. Another piece of evidence is all around us, affecting every moment of our lives: gravity. Gravity is the force that pulls objects towards each other. For a massive body like a planet, gravity pulls everything towards its center of mass. Imagine a planet forming from dust and gas in space. Gravity pulls all that material inward, equally in all directions. What's the natural shape that results from this uniform pull towards a central point? A sphere. It's the most efficient and stable shape for a large celestial body to take. This is why planets, moons, and stars are all spherical. A giant, flat disk planet is a physical impossibility. The immense gravitational forces would inevitably collapse it into a sphere. The gravity we feel pulling us down is actually pulling us toward the center of our spherical planet. That's why down is a relative direction, always pointing to the ground beneath your feet. No matter where you are on Earth, and of course, in the modern age, we have the ultimate confirmation. We've left our planet and looked back. Since the mid-20th century, we have sent countless satellites, probes, and people into space. Every single image, every video feed, every piece of data they send back tells the same story. High-resolution satellite imagery from services like Google Earth allows us to digitally circumnavigate the globe from our own homes. We can watch live feeds from the International Space Station, where astronauts float in microgravity with the stunning curve of the Earth as their constant backdrop. We can see weather systems swirling in massive, curved patterns. We can watch hurricanes rotate in different directions in the northern and southern hemispheres, a phenomenon known as the Coriolis effect, which is also a direct result of our planet's rotation. We can track airplane flights that take the shortest routes over the poles, routes that only make sense on a globe, not a flat map. The sheer volume of modern technological evidence is overwhelming. From the shadows of an eclipse observed by ancient Greeks, to the disappearing sails of a ship on the horizon, to the GPS in our phones that relies on a network of satellites orbiting a spherical Earth, the evidence is everywhere. It's woven into the fabric of our history, our science, and our everyday technology. Understanding that our world is a sphere isn't just a fun piece of trivia. It's fundamental to our understanding of physics, astronomy, and our place in the cosmos. It opens up a universe of possibilities, from global travel to space exploration. It reminds us that we are all passengers on this beautiful spinning sphere, a shared home in the vastness of space. So the next time you see a sunset, remember that you're not just watching the sun go down. You're witnessing the majestic rotation of our round planet, turning away from its star to bring on the night. The journey of discovery is never truly over, but on this question, the conclusion is clear. The evidence, from ancient logic to modern technology, all points to one undeniable truth. We live on a magnificent, beautiful, and most definitely round world. Thanks for joining me on this journey through evidence and discovery. If you enjoyed this exploration, be sure to like this video and subscribe for more deep dives into the wonders of our universe. See you next time.